So here we are, part 3, the last part of Module 10 or Module 17 in my class, networking. Let's just jump right in to the content. So as you can see, shorter module this time. We're going to talk about, explain how to follow network standards and protocols, so how those work and why we need them, and connect to network devices. So protocols are nothing more than rules. And when networking first came out, especially wireless networking, there were many different rules that were established by many different companies of which to create a wireless network. And the problem with that is if you wanted to create a Cisco network or combine Cisco equipment, well, you had to use their Cisco networking protocol. Okay, and so Cisco had a protocol and Linksys had a protocol, and they were different. So consequently, if somebody came to your house or you hired someone new, you would have to get a specific network card that spoke that language, okay, that spoke those rules. So consequently, what's happened with protocols now, okay, is that if there's a need for many devices to communicate, we're going to use standard protocols. So in the case of Wi-Fi, there's a protocol called the 802.11 protocol, and you may have heard of that, 802.11a, b, AC, N, AEX, all of those characters, right? Which are just different versions of that protocol. But the cool thing about having protocols is that whether it's wired or wirelessly, whether it's over the net, every computer is going to be able to communicate because all of the devices are programmed to use these same varied protocols, and thus all of them can communicate. Okay, so this might be, a protocol, say in a language, right, where we come up with a language that is not native to anyone else, but that everyone can learn to communicate with together, if that makes sense. So Ethernet, a family of networking technologies used for local area networks. Those are those wired connections, which defines wiring and signals. So in there are rules on, if you notice these wires up here, they're all wired the same way. They got the orange over here, etc. When I was first in school learning networking, I learned white, orange, orange, white, brown, brown, basically a color combination for how to wire these so that all of these could communicate. Okay. Now, network standards, protocols, and guidelines that ensure devices on a network can communicate and operate together. So these protocols are not just about the physical side or the wireless, okay, but they're also about how devices communicate. Now, this looks really crazy, and we don't need to memorize it for this class, but this is what's called the OSI, or the Open Source Interconnect 7-layer model. So anyone designing software is going to do certain things at each of these layers so that computers can communicate, okay, at different layers. So if you notice, the physical layer down here are those cables, the hub, the switches that we talked about, okay? Yeah, the hub that we talked about. And then data link, that's where the switch, so it starts moving traffic in routing patterns, okay? Network for packets, TCP, session, so how are we communicating, how fast, how slow, how much at a time, okay? But just know that this rule, or this set of protocols called TCP IP, okay, Transmission Control Protocol, Internet Protocol, this is what defines the IP address, by the way, allows all of these computers to communicate together. If we had different protocols, then computers wouldn't all be able to communicate. Okay. Then, of course, there's other protocols for cellular networks, and how cellular networks communicate so that different phone manufacturers, different carriers, okay, you don't have to have a specific phone on a specific carrier in order to communicate. So finally, a few more. We know sort of what Bluetooth is, right? Devices communicating within 30 feet. 9 meters. Today, 12 meters kind of does it. RFID, this is, that connection to your TV, okay? Still uses RFID, near field communication. So this would be your credit card that has the chip in it now that you tap, okay? Or smartphones have it that you tap, tickets that have it. And then IRDA, so remote controls, that's the specific protocol for your... Geez, Eric, lose your train of thought. For your remote controls, okay? So just a few other protocols to know. Bluetooth, that's associated with what's called a PAN, a personal area network, where devices can communicate in a short. Now, if we want to build a network at home, okay, we want to build that network for all of our devices at home, the first thing we're going to need to do is sign up for an ISP. Then we're going to need to either purchase or rent a modem, okay, or a separate wireless router. Today, normally, you'll get one that's a whole thing. People who want faster Wi-Fi know to go get better routers, better Wi-Fi routers, or a mesh network, many of these, to connect in the house to give a faster connection. And why is it faster? Because the signal is kept stronger throughout the home, okay? A lot of the devices you get from your ISP aren't going to have antennas or things that can break off, and thus the signal's not going to go as far, okay? We're going to get that Wi-Fi router. We're going to enable a wireless network. We're going to give it a name called SSID. So one of my neighbors has his SSID is pretty fly for a Wi-Fi, which is around the neighborhood. So that's what he calls his Wi-Fi network, okay? Configure a wireless network key. So we want to encrypt that network. We want to make it secure. So we're going to have a passkey that we only share with people that we trust, okay? Today, by the way, these Wi-Fi networks tend to come with the ability to set up two networks. One is a guest and one is a private, and I can't recommend that enough. If you have kids, you want to put them on the guest network. If you have IoT devices, which tend not to be as secure, you want to put them on the guest network. When you're accessing your bank account, accessing your retirement stuff, accessing things you trust, then you are on your private network away from all those vulnerable devices that exist today. So if you're going to go out and get a device today, make sure you get one where you can set up a guest network and a private network. Okay. Now, also the fact is there's usually two different radio frequencies, the 2.4 gigahertz and 5 gigahertz. And because those are different, when you set up one of these devices, you might actually see a 2.4 gigahertz and a 5 gigahertz network. Some devices connect at 2.4. 2.4 is going to be a longer, so if you've got a device that's far away from your Wi-Fi router, you may want to connect it at 2.4 so that it stays connected and has a reliable connection, but it's going to be slower. The 5 gigahertz signal is not going to go as far, but it's going to be a faster signal, thus you'll keep your bandwidth, more of your bandwidth, as you connect to Wi-Fi. Okay, so you've connected that up, you've enabled devices wireless functionality on the device, and then you just simply connect it to the network. You enter that wireless network key, that pass key, and you are connected to the World Wide Web. So in addition to those typical connections of Wi-Fi, there are Wi-Fi hotspots. These are these little devices that we can take and use remotely. Okay, T-Mobile has one, Verizon has one. Mobile hotspots is here. Wi-Fi hotspots are basically just where can I connect to Wi-Fi? This could be hotels. You see here, this is the Hotspot Cafe, right? Free Wi-Fi. So, they have Wi-Fi. People come drink coffee, buy things so that they can use the Wi-Fi. Okay? So, two types of different connections. Again, if you're going to connect to, someone else's Wi-Fi, make sure that it's secure. Do not do anything in the way of financial confidential information over that network. So finally, safety precautions for wireless networks: change that administrative password. So a lot of these come with default passwords. You want to make sure you change that, because all of those default passwords are readily available on the web, which means a hacker could get that password and try that as the first password and potentially get into your network if you haven't changed it. Change the wireless network name to something unique that only you would know. Yes, hackers can drive around and figure out where the signal's coming from, but it's a good practice as well. Enable that encryption, that WPA2, WPA3 encryption. You want to regularly change your wireless network key. Change that password. Okay, it is inconvenient, because then you got to go change it on all the devices that are connected. But if you've given it to someone who gave it to someone else, you want to re-secure your network. Regularly review the number of devices connected. So if you get into that Wi-Fi and get into the web interface, you can see the devices that are connected, and you just want to make sure you know all those devices and they're all trusted. Especially, by the way, if you're in apartments where there's many Wi-Fi connections, where someone might piggyback off your Wi-Fi so that they don't have to buy their own. Thus, they're gaming and you're wondering why your computers aren't connecting to the internet real well. It's because they're using all of your bandwidth. Okay? So, enable and configure MAC address control feature. So what this means is, in there, you can go look at the network interface card. You can find the MAC address. Okay? That's easily done. Let me show you. So what we're looking at here is a wired connection to my computer, okay? And you can see that I have a specific local IP address for my computer, and I can see an IPv4 address, I can see an IPv6 address, but I can see this physical address. And this physical address here, okay, is the MAC address. So what you're able to do with that is you can copy that down, and you can come in here and say, only this device with this MAC address, which a MAC address is unique to every computer, okay? Yes, there's a way to spoof it for those darn old hackers, but it is unique to every computer. Every wireless network interface card, wired network interface card, has a unique ID that we can put in a table, so only devices that we trust can actually get on our network, okay? Most people don't do this, but those security conscious people will, okay? It's an extra step when I need to add a device, but again, if it's on my private network, I want to keep hackers off, it's a way to do so. So choose a secure location for your wireless router. You want to make sure somebody can't get into your wireless router. They can't, physically assess it and manipulate it, okay? And then regularly perform router firmware updates. Most people, folks, do not update their router. They update their computer and the software on their computer, but they don't update the router. Now, you want to check with your ISP, because if you're running one, you want to make sure your ISP is updating it. Just like there's vulnerabilities in software, well, what is your router? It's basically software. So there's vulnerabilities that people will find and take advantage of. So you've got to get updates on your router. Okay? So let me know if you have any other questions. Have a great day, and we're done with networking. Take care.